Hi guys, I'm making my IGCSE Edexcel Physics top-up video for paper 2, going through what I consider to be the most important topics. So we're going to dip into transformers. Now I'm going to draw a basic structure of a transformer here. And so remember, you have an iron core, and whether it's a step up or step down transformer depends on the number of turns on both the primary and secondary coil. So if I show you here, this is the primary coil. Here's the secondary coil, just on the other side. Now because there are more turns on the secondary coil, it means that we must have a step-up transformer. Now notice that a step-up transformer increases the voltage. So where do you find one of these? Well, it's when electricity exits a power station. You want to have a step-up transformer because you want to increase the voltage to approximately 500,000 volts. And by doing that, it decreases the current, which is a good thing because current has a heating effect. So you don't want a high current because it would mean that all that energy would dissipate into the surroundings. So by decreasing the current, you prevent energy loss. However, when you get to your homes, you obviously can't have 500,000 volts entering your home because it would be incredibly dangerous. And so the main supply in a home is only 230 volts. And so in order to bring down that 500,000 volts to 230 volts, we need a step-down transformer. And if I draw a basic diagram here, a step-down transformer has fewer turns on the secondary coil, as you can see here, so it decreases the voltage output. Now if they ask you like a 5-mark answer as to how a transformer works, I'm going to help you now with your perfect answer, and that's basically using exam paper wording. So first of all, transformers step up or step down the voltage. And then how do they work? Well, you need an alternating current rather than a direct current. And the reason is because you need that alternating current to produce a magnetic field. So what happens is the current in the primary coil produces a magnetic field, and that current is changing. I've already said it's an alternating one, but it changes, which causes a changing magnetic field in the core. Then we need to state that the magnetic field interacts with the secondary coil, inducing a voltage, which is how we either step it up or step it down. So quite a long, annoying answer here, but if you're keen to get full marks in this long transformer question, this is the sort of answer you need to be giving. And then don't forget, you need a couple of equations associated with this, which is that Vp over Vs equals Np over Ns. So what that states is that the voltage in the primary coil divided by the voltage in the secondary coil is equal to the number of turns on the primary coil and the number of turns on the secondary coil. There's another equation you need to be aware of, which is that power input equals power output. And here you have voltage primary times current primary equals voltage secondary times current secondary. So just be prepared to substitute your numbers into the equation. Looking now at static electricity, ideally a collision or a recoil velocity, there's not too much to be concerned with here. As I always tell my tutees, the answer tends to always be that friction causes the transfer of electrons. So Why did a man walking along a plastic carpet become statically charged? Well, that's because friction between his feet and the carpet caused the transfer of electrons. Why did the child sliding down a plastic slide become electrically charged? That's because friction between their bum and the slide caused the transfer of electrons. Why does an aeroplane get charged when it flies through the sky? Because of friction between the plane and the clouds causing the transfer of electrons. So try and use this wording where possible. Notice with static electricity you need an electrical insulator, such as plastic. Like, it would only happen on a plastic slide that the kid would become charged. It wouldn't happen on a metal slide because metal is a good conductor. Because it has delocalized electrons. If they ask you why rubbing your hair with a balloon means that it all stands up on end, well, that's because, again, so your hair stands up on end when you rub it with a balloon. Why? Because I've already said, due to friction causing the transfer of electrons, and all the hairs become negatively charged. And remember, negative charges repel, meaning that the hair stands up on end like this. Oh, artist in the making. Uses, remember, the electric paint spraying. You give the paint all the same charge, so it forms a fine mist due to paint droplets repelling. And therefore you get a better finish on the bike and you waste less paint. Don't forget dangers associated with it. So remember, fuel tankers are airplanes. Because the plane becomes charged due to friction causing the transfer of electrons. Now, when the fuel tanker comes close, there could be a spark leading to a huge explosion. So instead you need a metal strip attached to the plane. Allows excess charge to be earthed. So I thought the best way to show you momentum is to go through some calculations, just to remind you that momentum is an example of a vector quantity. And the easiest thing to do here is remember that a vector contains both a magnitude, so a size, and a direction, whereas a scalar quantity is magnitude only. In terms of remembering what falls into what category, the easiest thing to do here is remember which are the vector quantities and then remember that absolutely everything else is scalar. So your vector quantities include weight, force, velocity, momentum, displacement, acceleration. Anyway, let's have a look at these questions. Complete the table ticking the boxes to show which quantities are vectors and which are scalars. So because I've already listed that, I know that force is a vector, velocity is a vector, so everything else is scalar. The car travels at 20 meters per second. The mass of the car is 1500 kilograms. State the equation linking momentum, mass and velocity. So momentum equals mass times velocity. Calculate the momentum of the car, so we substitute those numbers given in the question into the equation. So that's 1500 times 20 to get 30,000 kj meters per second. In a crash test, a car runs into a wall and stops. The momentum of the car before the crash is 22,500 kg meters per second. The car stops in 0.14 seconds. Calculate the average force on the car during the crash. So force equals change in momentum over time. So that's 22,500 divided by 0.14 to get 160,000 newtons as your force. Use ideas about momentum to explain how seatbelts can reduce injuries to passengers during a crash. Now, this question gets dressed up in lots of different ways, like how does an airbag work? How do crumple zones work? and I promise the answer is always the same. And remember, in physics, you always want to provide equations where possible. So what you first of all state is that the same change in momentum occurs, but over a longer time frame is what the chromosomes, seat belts, etc. do. And then, according to the equation, let's state the equation. Force equals change in momentum over time. A smaller force is felt by the passenger. And then just to show you another type of momentum calculation, because I know people don't like this, a boy of mass 43.2 kilograms runs and jumps onto a stationary skateboard. The boy lands on the skateboard with a horizontal velocity of 4.1 meters per second. State the relationship between momentum, mass and velocity. So momentum equals mass times velocity. The skateboard has a mass of 2.5 kilograms, so there's its mass. Skateboard. Here's the mass of the boy. Using ideas about conservation of momentum, calculate the combined velocity of the boy and the skateboard just after the boy lands on it. Now notice we're using ideas of conservation of momentum, so even if you can't do the maths, if you simply state momentum before equals momentum after, you get a mark, so don't forget to do that. So the very first thing you want to point out is, because of this conservation of momentum, you know that the momentum before equals the momentum after. So let's have a look at the momentum before so we can work this out. Well, we know the skateboard is stationary, so we know its initial speed is 0. And then we know that the mass of the skateboard is 2.5 kilograms. Now let's work out the momentum of the boy. So his mass was 43.2 and his velocity was 4.1. And then their momentum afterwards, well, they're basically combined as one object, because it says here that they have a combined velocity and the boy's obviously standing on the skateboard. So we need to add their masses, so that's 2.5 for the skateboard plus 43.2 for the boy, and then multiply it by their combined velocity, which is what we're after. So now we need to sort out the maths. So 43.2 times 4.1 is 177.12. 0 times 2.5, remember that just disappears. Do 2.5 plus 43.2 to get 45.7 V, and then divide both sides by 45.7. And therefore V equals 3.88 meters per second, three significant figures. The boy holds a heavy ball as he stands on a stationary skateboard. The boy throws the ball forwards while still standing on the skateboard. Explain what happens to the boy and the skateboard. This is quite a hard question, but use your common sense here. You know that the boy and the skateboard must move backwards, so in the opposite direction of the ball. And why is that? Well, that's due to the conservation of momentum. And you can state the appropriate Newton's law here, which is Newton's third law, for an additional mark. Now we're going to look at moments. So remember that moments are turning effects, or turning force. So spanners use moments in order to help undo nuts and bolts. We can consider moments when we open a door, because remember, if you add a greater force, then it'll be easier to open the door, and if you actually push the door from the side furthest from the pivot, so the hinge, it will make it easier too. And that's due to this equation, which you need to learn. Moment equals force times distance. Notice that the units of force is newtons, the unit of distance is meters, so the unit for moment is Newton meters. So the best thing to do here is to look at an example of a question. So the diagram shows a gate with a lever operated catch. A loop on the bolt fits around the lever arm at A. Describe how the lever arm is used to move the bolt. So have a look at this diagram. It's a gate, so effectively you want to pull that lever, so B, to the left, and what that will do is will cause the bolt to slide open. So that's quite straightforward. First of all, just state the lever arm moves to the left. Why is the spring needed? Well, think about how this gate works. Effectively, you need the lever arm to return to its original position, and the spring will allow you to do this. The lever arm operates using the principle of moments. State the principle of moments. This is something you need to learn off by heart, which states that clockwise moments equal anti-clockwise moments. So the force applied at point B is 22 newtons. The pivot is 110 centimetres from point B and 38 centimetres from point A. Calculate the force exerted on the lever arm at point A by the spring. So this sounds hard, but I promise we can work this out. So we're going to write out the principle of moments again. So clockwise moments equal anti-clockwise moments. So let's have a look at what we have. The force applied at point B is 22 newtons and the pivot is 110 centimetres away from point B. Careful with units, let's convert that straight to metres, and the same with this value here so we don't screw up. So we know that point B has a force exerted on it which is 22 newtons, and we know that the pivot, so down here, is 1.1 metres away, so this is effectively the anti-clockwise moment. So let's write that down below. So that will be 22 times 1.1. And then looking at the information about point A, we know that the pivot is 38 centimetres away from point A. So that's 0.38 metres away. And we need to find the force exerted on the lever arm at point A. So that's effectively heading in that direction. So we're looking for this force here. So we do here 0.38 metres times what we're after and then work out everything else. So then simplify, so we'll do the right hand side first of all. So 22 times 1.1 equals 24.2 equals 0.38x. Divide both sides by 0.38 in order to find out x, to get a value which is 63.7 newtons to 3 significant figures. Explain how the force applied at point B would need to change if the distance from the pivot to point A is increased. So we're asking, what happens if we increase this distance along here? What do we need to do to this force here? Well, if you were to increase the distance, then effectively the moment or the turning effect would be greater around A. So we would need to add greater force at B in order to compensate for that. So just write, since the distance to A has increased, the moment around A increases. So therefore, a greater force will be needed at B. So yeah, I thought the best way to show you how to approach moments is pick a pretty disgusting one. Don't forget this statement up here. So first of all, here's the equation for calculating moments, and this statement here, the principle of moments, that tends to come up when we look at these questions, so you can definitely start by guessing the initial marks. Let's quickly chat about ultrasound. So remember, the range of human hearing is between 20 to 20,000 hertz. And that anything above 20,000 hertz we can't hear, and therefore is considered as being ultrasound. So ultrasound's definition is it's a longitudinal sound wave above the range of human hearing, so above 20,000 hertz. Let's write that here. So I've just told you that a sound wave is a longitudinal wave. However, sometimes we like to display sound waves on a screen, and the easiest way to do this is using both a microphone in order to pick up the sound wave and then an oscilloscope in order to display the sound wave on a screen. So you'll end up with a trace which looks a bit like this. Now don't forget that this distance, be very specific as to how you draw this. This is the wavelength of the wave, so the distance between two peaks or indeed two troughs, and that this distance here is the amplitude. Now remember, the amplitude relates to how loud a sound is. So the higher the amplitude, the louder the sound. Wavelength or frequency is all to do with how high a sound is, so its pitch. So if you have a shorter wavelength, then clearly you're going to have a higher frequency. And that's because you have more waves per second. And so effectively the waves get closer together. And remember that a higher frequency links to a higher pitch. So a higher sound. Whereas a low frequency would relate to a low pitch, so a low sound. So let's just compare a couple of waves. I'm just going to hand draw. So what do you think this wave would sound like? Well, let's have a look first of all at the amplitude. So it's got a low amplitude, which means it has a low volume, so it's quiet. And now let's look at its frequency. Well, because it has a short wavelength, it has a high frequency. Don't forget that frequency is measured in hertz. And therefore it's going to be a high sound, so a high pitched sound. Taking a different wave, this time we can see that in comparison we've increased the amplitude, so we have a high amplitude, which means we have a loud sound due to its high volume. And then have a look at this wavelength. Well, you can see that it's gotten much longer, so that means the frequency has decreased, so it has a low frequency, so we have a low pitched sound. And you must be prepared to draw this on any diagram they give you. Let's do a little bit on cosmology. So first of all, the Big Bang Theory. Now this is one of the theories scientists put forward as being the beginning of our universe. So let's just state what it is. We state that the universe is expanding after exploding suddenly in a big bang from a very small point. And notice that space, time and matter were created in the Big Bang. So what are the pieces of evidence which support it? First of all, redshift. Now notice that light from distant galaxies is redshifted, so appears more red. And the only reason for that is because the wavelength has increased of the light. And the only reason for that can be the fact that they're moving away from us. So the universe must be expanding, which means that it must have started out as the Big Bang. The second piece of evidence is CMBR, which stands for Cosmic Microwave Background Radiation. And this is radiation which is present throughout the universe. So if they ask you for the evidence to support the Big Bang Theory, you need to state redshift and CMBR. Right guys, I really hope you found this video helpful as a nice top up to your knowledge. Let me know how your exam goes, and I hope